Hello everybody, today will be the last day of our quadratic unit, so we're looking at finding the equation in vertex form. So in order to determine the quadratic in vertex form, you must have at least the vertex given to you and one other point on the parabola. So that point can be a couple of options. So it could just be simply listed as a point that says this point is on a curve, or this quadratic runs through this point. Or you might have them use an x or a y intercept. If that's the case, just a reminder about the x and y intercepts. So an x-intercept, they always have a y value of 0. So if I said that the x-intercept was 6, then your point would be 6, 0, because y is equal to 0. Vice versa, if I give you the y-intercept, any y-intercept has a x value of 0. So if the y-intercept is 6, then the point itself is 0, 6 that you'd be using for your problem. Okay, the easiest way to look at this is just jump right into a problem here. So it says determine the equation of the quadratic function with the vertex 2, 6, and it passes through the point 8, negative 12. You always want to start yourself out with the general form of a quadratic for vertex form, which is this. Okay, well, let's plug in the information that we know. We know the vertex is 2, 6, and we have that point 8, negative 12. This y value right here, that's our negative 12. A, we don't know. X is 8. H is the x value of our vertex, which is 2, but we need to make sure we plug it in opposite as negative 2. And then our k value is the y value of our vertex. Now the whole point of determining these equations is essentially we're identifying what that a value is. Okay, if I keep going here, 8 minus 2, that's 6 squared, that gives me 36. Okay, I'm going to bring this 6 over to the other side to isolate that a, which becomes negative 12 minus 6 equals 36a. So I've just rearranged and expanded this here. Negative 18 equals 36a. I would divide both sides by 36. And you will be left with, if you reduce this fraction here, negative 1/2. So you've solved that. Your a value is, therefore all you have to do is rewrite your equation with your a value and your vertex. Well, a is negative 1/2. And the vertex portion was given to us in the question. And there you have the equation in vertex form. Okay, this is a question involving one of the intercepts. So determine the equation of the quadratic function with a vertex 2, 3 and a y-intercept of 11. So this point right here, remembering, is 0, 11, because any y-intercept has an x value of 0. So the same thing, you're going to want to start with your general form for a vertex form quadratic. You're going to continue that, so plug in what you know. Y-intercept 11, well, that's y. A, we don't know. X would be 0 because of our y-intercept. H is negative 2 because our vertex is at 2, and it's opposite. And k is 3 here. Okay, so 0 minus 2 squared, well, that's 4 plus 3 here. Same thing, I'm going to solve. 11 minus 3 equals 4a. This equals 9. Divide both sides by 4. Divide both sides by 4. And our a value is going to remain as 9 over 4 because that fraction has been reduced into lowest terms. And the last step here would simply be rewriting the equation with our a value, 9 over 4, x minus 2 squared plus 3, and that would be your equation in vertex form. Okay, and our last one is similar, but it's asking to determine the equation in standard form, okay, that has a vertex and it passes through this point. So anytime a question gives you the vertex, you're going to actually have to start with vertex form and then work your way to standard form. Okay, so we're going to go through the same steps we just did to come up with vertex form first, and then we're going to use our vertex form equation to determine the standard form equation. We're not going to use any decimals, fractions if they appear. Okay, and I've made that little note there that for you to write down or review before you do some of these problems. Okay, so looking at the information, our vertex is -2, 9. Okay, and our point that we're going to be using is 4, -3. Just like we were doing in the previous examples, let's start with the general form equation for vertex form, which is this. We're going to plug in all the information we know. So y is -3, x is 4, our vertex is -2, 9. Make sure you plug it in its opposite for your h value, and you're going to go ahead and solve this. 4 plus 2, that's 6, squared is 36. Okay, well, -3, going to bring the 9 over here, subtract 9, equals 36a. That would be -12 equals 36a. Divide both sides by 36, divide both sides by 36, and a would be equal to, if you reduce that, -1/3. So you could say at this point your equation in vertex form is -1/3 x plus 2 squared plus 9. Okay, but that is only halfway done our problem. Okay, we need to figure out what the equation is in standard form. In order to find out what we're looking at in standard form, we need to expand vertex form and collect our like terms. Well, let's do that. Our equation, remembering, is -1/3 x plus 2 squared plus 9. The first thing when I say expand is you want to look at this portion of your equation first. Remembering what it means to actually square a number or a variable, it means to multiply it by itself. So if you have x plus 2, that entire set in brackets squared, you're essentially saying it's x plus 2 times x plus 2, and that plus 9 still exists. What you want to do is use FOIL, okay, which we know and have looked at here, in order to expand that. So first terms, you're going to have x times x, which would give you x squared. You're going to have x times 2, which is 2x, 2 times x, which is 2x, and 2 times 2, which is 4. You would combine your like terms and simplify what you have in the brackets, which is x squared plus 4x plus 4. And at this point, what you want to do is distributive property. So that 1/3 in front of your brackets, you're going to distribute into each term inside the brackets by order of multiplication. 1/3 times x squared is 1/3 x squared. Okay, 1/3, -1/3 times 4 is just -4/3, and x, and then the same thing here, -4/3, and you still have this plus 9. If you want to simply look at how we did that multiplication here, well, -1/3 times 4, that's the same as -1/3 times 4/1. You multiply your numerators and denominators, and you're left with -4/3. Okay. What we need to do here is now collect our like terms. Our only like terms are this -4/3 and 9, and in order to collect the like terms, because we have fractions, we need to find a common denominator between those two values. The common denominator is 3, and if I make 9 into a denominator of 3, it's going to become 27 over 3. The last thing we need to do is simply just add these two fractions together, and we should get our quadratic in standard form. Negative 4 over 3 plus 27, add your numerators, you're left with 23 over 3. And that is standard form. Okay, this one's a little trickier because we're involving fractions, but again, we're not using decimals, we keep these things as fractions. Reference this example for help. It follows the same steps every time. Let me know if you have any questions. Good luck.